CAP theorem in system design. Hello, everyone. Today I'd like to walk through the CAP theorem in distributed systems. CAP is one of the most fundamental concepts, but also one of the most misunderstood, because in practice, it's not just a theory, it's a decision framework under failure. When I think about CAP, I usually break it down into 4 aspects. First, what CAP actually means in real systems. Second, the trade-off between consistency and availability. Third, how it maps to user-facing requirements. And finally, how real systems implement these trade-offs. What CAP actually means. CAP stands for consistency, availability, and partition tolerance. Consistency means all nodes see the same data. Availability means every request gets a response. Partition tolerance means the system continues despite network failures. But here's the key insight. Partition is not optional. In any real distributed system, network failures will happen. So the real decision is not between C, A, and P. It's between consistency and availability when partition happens. Consistency versus availability. Let's start with CP systems. These systems prioritize consistency. If the system cannot guarantee correct data, it may reject or delay requests. For example, in a payment system, it's better to reject a transaction than to process an incorrect one. So the key idea is CP systems fail by becoming unavailable. Now let's look at AP systems. These systems prioritize availability. They always respond even if the data may be stale. For example, in a social feed, it is acceptable to show slightly outdated content. So the key idea is AP systems fail by returning inconsistent data. Mapping CAP to user requirements. Here's the most important part. CAP is not a system-level choice. It is a per-use case decision. For payments, we choose consistency. It is better to fail than to be wrong. For social feeds, we prefer availability. Users tolerate stale data, but not downtime. For user profiles, we often use a hybrid approach, ensuring read your rights consistency while allowing eventual consistency globally. So the key idea is different parts of the system make different CAP decisions. Failure scenarios. Let's look at what happens during failures. First, network partition. CP systems may reject requests. AP systems continue serving requests but may diverge. Second, split brain scenarios. 2 nodes accept rights independently. CP systems prevent this via leader election. AP systems allow it and resolve conflicts later. Third, data divergence. In AP systems, replicas may temporarily disagree. We resolve this with last right wins, versioning, or CRDTs. So the key idea is failures reveal the true behavior of your system. Real-world design patterns. In practice, most systems are hybrid. We use CP for critical paths and AP for scalable paths. Leader-based systems enforce consistency. Eventually, consistent systems prioritize availability. In multi-region systems, we often use strong consistency within a region and eventual consistency across regions. So the key idea is real systems combine CAP trade-offs at different layers. Summary to summarize. CAP is not about choosing a system type. It is about deciding how your system behaves under failure. CP systems ensure correctness. AP systems ensure availability. Closing insight to conclude. The best systems don't eliminate trade-offs. They make them explicit and align them with user expectations. Because in the end, system design is about choosing the right failure mode. Thank you.